Welcome to the third session on elementary number theory. This is the second session on division algorithm. So we are going to recall division algorithm and try to give a streamlined proof as you would see in a textbook, then give some applications. Okay, let us get started. Yeah, I think I forgot to say this is my YouTube channel, youtube.com/C for channel Kumar HCU. And anything related to my videos, please send email to this kumaresa.zoom@gmail.com. Yeah, and you can also download the list of videos. Let me just see whether I have to do Zoom page width. Yeah, you may also download the list of videos on my channel by going to this site, or you can scan. Search for list of videos. The list gives descriptions, links of videos, and they are arranged in preferred order of viewing so that learning will be in proper order. And if you help, it will also be periodically updated. If you are interested in a series, if you watch all of them, okay, please put it in Excel sheet and send it to me. Okay, right. So now let's get started. Elementary number theory. So what did division algorithm say? Let us recall. It said that let b be an integer and a be a natural number, then there exists a unique q and r so that in z, okay, so that 1 b is a q plus r and 2 is 0 less than or equal to r less than a. Okay, now we already proved it, we motivated the proof, but let's try to see how you will find it in a textbook. So consider the set. See, all these things will look mysterious, but we understood what it was yesterday. B minus ak, where k is in z. Notice that this is not empty because b belongs to this with k equal to 0. Alright? Okay. And what we want, let s plus denote the set of x in x so that x is greater than or equal to 0. We want to claim s plus is not empty. Okay, the way we did that was, suppose b is positive, okay, greater than or equal to 0, then okay, since b belong to that, b belong to s, therefore b belong to s plus, right? Suppose b is negative, then what we did was, let us look at mod b. Then what is the relation between b and mod b? B is less than or equal to mod b, because mod b is, okay, maximum of b and minus b, right? Either b is positive, b is negative, accordingly this is equal, right? Now a is a natural number, therefore a is greater than or equal to 1, therefore you multiply a, this equality, by mod b, therefore mod b into a is greater than or equal to mod b. That in turn is greater than or equal to a. Therefore, okay, sorry, greater than or equal to b. Therefore mod b times a minus b is greater than or equal to 0. Is that okay? Yeah. So we got it. So that is our a. Just 1 second. So since we want the other way around, what we want is there exists a k so that b minus a k is greater than or equal to 0. I want to say I am going to take a as minus b. Okay, let us do that. Okay, so since b, notice that mod b is maximum of b and minus b, therefore minus b will also be less than or equal to mod b. Therefore a is greater than or equal to 1, mod b times a is greater than or equal to mod b, which is greater than or equal to minus b. Therefore mod b plus a plus b is greater than or equal to 0, that is b plus, okay, mod b plus a is greater than equal to 0. Therefore, if we take k equal to minus of mod b, I'm through, which is same as b. B is negative. Remember that? Okay. Right. Therefore, S plus is non-empty. Therefore, let R by well ordering principle there exists R in S plus such that R is the least element of S plus. Okay. Now, since R belongs to S plus and which is contained in S, there exists a Q, an integer, so that any element of R is of the form b minus ak. Therefore, it must be of the form R must be b minus ak. This is Q. Okay. Now we want to claim R is satisfy this thing, strictly less than a. Okay. Right. Now notice that since R belongs to S plus, R is already greater than or equal to 0. This part is okay. And suppose R is greater than or equal to A, then we want to arrive at a contradiction. If R is greater than or equal to A, then R minus A is greater than or equal to 0. But what is R minus A? R minus A is B minus AQ minus A, that is greater than or equal to 0. That means B minus A into Q plus 1 is greater than or equal to 0. If I take Q plus 1 equal to K, then this is how B minus AK is greater than or equal to 0. And what is this? B minus AK is an element of S and it's greater than or equal to 0. It's an element of S plus. But that object, okay, right? So, do you follow that? This is greater than or equal to 0. Therefore, I have R minus A is greater than or equal to 0. Now, notice that R minus A, okay, is strictly less than R since A is positive. But R minus A is an element of S plus because this fellow is R minus A. So R minus A is an element of S plus. R minus A is strictly less than R. This contradicts the choice of R when R is the minimal, the least element of S plus. Therefore, R is strictly less than A. Then uniqueness part is exactly like last time. Suppose B equal to AQ1 plus R1, which is also equal to AQ plus R. Okay, assume that. Okay, without loss of generality, maybe I will write AQ to R2. Okay, R2 is greater than R1. Okay, claim R1 equal to R2. If not, okay, assume that R2 is greater than R1. Then R2 minus R1 is strictly positive. But what is R2? R2 is B minus AQ2 minus R1 is B minus AQ1, that is equal to, are you following? A into Q1 minus Q2. This is equal to, right? This is positive. Remember, A is positive, right? This is a natural number. Therefore, Q1 minus Q2 is positive. Okay, right? Now notice that what I have is R2 minus R1 is positive. Okay, right? Okay. Now what is R1 minus R2? That is again of that form. R1 minus R2 is something like this form. Now notice that R2 is strictly less than A and R1 is greater than or equal to 0. Therefore, R2 minus R1 is strictly less than or equal to R2, but that's less than A. Right? You understand that? Therefore, R2 minus R1, A is strictly less than this. This is strictly less than A. Right? But what is this? But R2 minus R1 is A into Q1 minus Q2. But we know Q1 minus Q2 is positive, it's an integer, therefore q1 minus q2 is a natural number, right? Therefore q1 minus q2 must be greater than or equal to 1. Therefore a times q1 minus q2, because a1 is also a natural number, that's greater than or equal to a. Therefore this is greater than or equal to a. Okay, this is a contradiction. Hence we conclude R1 equal to R2. Since R1 is R2, B equal to AQ1 plus R, call it R, equal to AQ2 plus R. This implies AQ1 equal to AQ2. That implies A into Q1 minus Q2 is 0. So A is not equal to 0. That implies Q1 minus Q2 is 0. That implies Q1 equal to Q2. That is the proof. Okay, right. You can see that I wanted to give a textbook proof, but I started again thinking here. Okay, right. Okay, pause, review, proceed. Now let's look at some applications of division algorithm. Remember that division algorithm is the most important tool whenever we study multiplicative property. That is, we are talking about divisibility, factor, etc. This is the one. Okay, let us go slow. I will give some very simple minded 5 or 6 applications. Okay, let us start with the first application. So suppose I have a natural number n. Okay, I say n is even. Okay, so if I write n by using division algorithm, I can write it as 2k plus 1. Suppose I take my b equal to n and a equal to 2. Using division algorithm, I can write n equal to 2k plus some r. But what is r? 0 less than or equal to r. R is should be less than 2, and r is an integer, right? Therefore r must be either 0 or 1. Therefore n is of the form 2k plus 0 or 2k plus 1, right? If n equal to 2 is of the form 2k, then I call n is even, and in this case I call is n is odd. So that is when, so you remember when you write b equal to aq plus r, this r is called the remainder. So what does it say is, when n is divided by 2, if the remainder is 0, I call n is even. If the remainder is 1, I call it n is odd, right? So can an integer be both, n be both odd and even simultaneously? It looks like a very easy trivial question. In fact, some of you may even think it's a stupid question. But think about, to answer this, we have to use uniqueness of the division, uniqueness part of the division algorithm. What does it say? It says, when you give me an integer n, then n is exactly of the form 2 power r, 2k plus r, where 0 less than or equal to r less than 2. Okay, therefore r has to be either 0 or 1. That this r is unique. This k is also unique, right? Therefore if it is both even and odd, what does it mean? Then n also I can write as sometimes 2 power m, and n I can write as 2k plus 1 also. Are you following? When I say it is even, it should be of the form 2 times m. If I say n is odd, it should be 2k plus 1. So write it. You understand? But what does it mean? If I apply divisional algorithm, I know n must be 2q plus r, where 0 less than or equal to r less than 2. That means r has to be either 0 or 1. This is unique, right? So I have already written it, right? Therefore n equal to 2q plus r. Therefore my r has to be this. right? So you are written n as 2q plus 0, 2q plus 1, therefore that would mean r has to be 0 or 1. That's a contradiction. Please understand, we are using uniqueness part of the division algorithm. Okay, you are taken it for granted from high school days, you may find it little challenging. Please understand. Okay, when I write n is even, it should be of the form 2 times m for some integer m. When you say n is odd, it should be 2k plus 1. But it means, okay, if I apply n, if I write 2m plus 1, that means this I had 0 must be the remainder, because that's a unique thing. Or when you write n equal to 2k plus 1 is the remainder, but I know the remainder is unique. It cannot be 0 as well as 1. Therefore, this contradiction shows it cannot be both even and odd. Okay. So, please go through this argument. Don't take it for granted. To make you really appreciate, even if you get confused, don't worry. Okay, slowly, after a day or two, you will understand the full gist. Okay, all of us, whenever there is something which kind of challenges our understanding, our earlier held belief, okay, we are always confused. Okay, so be it religion, be it political discourse, or be it philosophy, or be it in mathematics also, all these things happen. Okay, for example, in the high school, what you said was the simply thing. You say an integer n is even if it is a multiple of 2, otherwise odd. You see, this is mutually exclusive. So what does that mean? For example, if you give me a real number a in R, then I know what is meant by saying a is rational. If I can write a as p by q, where p and q are integers and q not equal to 0, right? And I say it's irrational if a is not rational. You understand? Therefore, they are mutually exclusive. A number, real number, cannot be both rational as well as irrational. Do you understand that subtlety? Okay. In high school, this is the way you define. Okay. If n is even, if it is a multiple of 2, otherwise it's odd. You never worried about when I divide by 2 what I get. Yeah. Okay. I know how to define rational. Anything not rational is irrational. Here, anything not even is odd. Here what we are saying, I am defining even and odd by looking at division algorithm. Okay. If you are a BSc student, it will be really difficult. Okay, please go through it. These are the things which usually people don't spend time. As I said, conceptual, logical understanding of things is very important. Are you really frightened or confused? Okay, so we have two definitions. Using division algorithm, I say n is an even integer if the remainder is 0, and n is an odd integer if the remainder is 1. Okay, and this notion is well defined because the only possible remainders are 0 or 1. Do you understand? Whereas in high school, I said n is an even integer if n is a multiple of 2, and anything else is an odd integer. If it is not an even integer, it is an odd integer. It is a mutually exclusive. Right? Now what we are saying with these two definitions are the same. Okay? Think about, don't get confused. Okay? If you want to understand 30-40%, slowly things will improve. Okay? Be at it. Don't worry. Okay. So now let's do a few more examples. So I say integers a and b have the same parity. This is standard. This is application number 2. These are the technical terms you should learn. Okay, if either both are even or both are odd. That is, A is even if only B is even. A is odd if only B is odd. They have the same parity. That means when I divide A by 2, okay, divisional algorithm will give me, if it gives me 0 as the remainder for A, then 0 will be the remainder for B. And similarly, if I divide A by 2, if I get 1 as the remainder, I will get the same remainder when I divide B by 2. Okay, understand? So I want to say that, okay, so for give me any integer n, for any integer n, okay, n and n squared have the same parity. Now how do I do that? Okay, so many of you have problem with this problem solving also. So one of the trick is you go back to the definition. So what does it mean to have the same parity? Either both are even or both are odd. How do I know about even or odd? By using our definition of which uses division algorithm. That is, okay, what does it mean? When I divide n by 2, okay, what is the remainder? Either 0. If n has a remainder 0, then n squared also should have remainder 0. That's all I have to prove. And conversely, okay, let us do that. Okay, so since n is an integer, then I know either n is of the form 2k or n is of the form 2k plus 1, right? Then now let us look at what is n squared. N squared is 2k squared, which is 4k squared, which is 2 times 2k squared. That is 2 times n. Therefore, this is even. If n is even, then n squared is also even. You understand that? And if n is odd, what is n squared? 2k plus 1 whole squared, which is 4k squared plus 4k plus 1, that is 2 into 2k squared plus 2k plus 1. I hope I did everything correctly. Yeah, so this is something like m, 2m plus 1. Therefore, if n is odd, then n squared is also odd. Okay, is that okay? And because of division algorithm, n squared has to be only this way. There is no other way. I wrote as 2 times 2k squared. This is the only possible way. Remember, by division algorithm, I should be able to write n squared as, okay, some 2 times q plus r, where r should be 0 less than or less than 2. Right? But I had already written n squared equal to 2 times this m, which is 2k squared. Okay, by the uniqueness part, I know there is no other way. Okay, these are the things which are usually not emphasized. You simply go through. We are using uniqueness part. Here also the same way. Okay, n squared I wrote as 2 times some number m plus 1, and I know this is of the form some 2q plus r, where r is between 0 and 1. Right, this r is between 0 and 1. Yes, and I have written it as 2m plus 1. By the uniqueness part, this must be the remainder, therefore this must be the quotient. That means n squared must be odd. Okay, these are the things which are never spelled out. You simply compute, I think the proof is over. Okay, this is what I find in many number theory courses happening. Please pay attention, there is a logic involved, go through it. For every natural number n, we want to say 3 is a divisor of n squared minus n. I hope I am writing it correctly. Let us see. Yeah, how will I do that? See, now the standard trick how to use division algorithm whenever you say some such thing is you try to write n, I apply the division algorithm to this number. For example, when I wanted to say the same parity, I applied division algorithm where the divisor is 2. When I want to say something about 3, then I should apply the division algorithm where my a is 3. Okay, so basic idea is try to write your b as a times q. So you have to identify what is the division algorithm I have to use, what is the divisor I have to use. Since I want to say 3, then I have to write 3. Therefore, what are the possibilities? We know n must be some 3q plus r, where r is 0 less than or equal to r less than or equal to less than 3. Therefore, r must be either 0 or 1 or 2. Therefore, n I can write, I should be able to write as 3k or 3k plus 1 or 3k plus 2. Exactly only one will happen. That is again division algorithm. Okay, n cannot be 3k, n cannot be again 3, not 3k plus 1, maybe for some other m 3m plus 1. N cannot be 3k also equal to 3m plus 1 or equal to 3n plus 2 or let us say 3l plus 2. You understand? It cannot happen. Do you understand this? Division algorithm says it cannot, because I am writing this with the remainder 0 less than or equal to or less than strictly less than 3. Similarly here, by uniqueness part, then here it is 0. So you see that there is a contradiction. So exactly only one will happen, right? Now what is n squared minus n? Algebra taught us this is nothing other than n squared into n minus 1, but that is n into n minus 1 into n plus 1, right? Therefore if you want to write n minus 1 into n plus 1, you understand? Now therefore these are three consecutive integers, right? So what are the possibilities? Suppose n equal to 3k, it is already there, therefore this is divisible by 3. Do you understand? If n is 3k, this will be n minus 1 into 3k into n plus 1, therefore 3 times something, therefore this is divisible by 3. Okay, suppose n equal to 3k plus 1, then you can see that I can use n minus 1 will be 3k plus 1 minus 1, which will be 3k. Therefore again n squared minus n will be 3k into n plus 1. And suppose n equal to 3k plus 2, okay, now I will use this fellow, therefore n plus 1 will be 3k plus 2 plus 1, which is 3 into k plus 1, right? Therefore my n squared minus n will be n into n minus 1 into 3 into k plus 1. N also you can substitute, I don't want to do that. So what I have shown? I have shown 3 divides n squared minus n for any natural number n. Pause, review, proceed. Okay, now let us do a combination. Suppose n is odd, okay, then I want to say n 8 divides n squared minus 1 always. I hope I do it correctly. Okay, right? So n is odd, therefore n is of the form 2k plus 1. Therefore what is n? N squared? N squared is 2k plus 1 whole squared. Remember, whenever you say odd, then what should be my a and divisional? I have to use in divisional algorithm. A must be 2. Okay, so I apply that, so I get this, and this is unique, and this is going to be 4k squared plus 4k plus 1, okay, minus 1. You understand that? There is n squared minus, so n squared minus 1. This is minus 1. That is equal to 4k squared plus 4k, which is 4k into k plus 1. You understand? Now you can see n squared minus 1, 4 already divides, right? Right? Now let us write it is 4 into m. But what is m? M is k into k plus 1, right? Now k is also an integer. Therefore my k, either it is of the form some say 2r, let us say 2, okay, I don't want the r, you should not think of the remainder, let us say 2s, where s is an integer, or 2s plus 1. Okay, if k is 2s, you can see 2 divides m, right? If k is 2s, then it is 2s into s plus 1, 2s plus 1. Therefore this will be 4 into 2s into s plus 2s plus 1, that is 8 into s into 2s plus 1. Therefore 8 divides. Yeah, right. What is the other case now? This is the case where my k is 2s. Suppose my k is 2s plus 1, right? Then I can, what is k plus 1? K plus 1 will be 2s plus 1 plus 1, which is 2 into s plus 1, right? You understand that, right? Therefore my n squared minus 1, I am looking at this 4k into k plus 1 is 2 into s plus 1, therefore 8 into k into s plus 1, therefore 8 divides again. Okay, pause, review, proceed. So let us look at the last application. For every integer n squared is of the form something to do with 4k. Okay, I do not know 4k plus something or 4k plus something. Okay, we will find out. You understand? I want to say 4k plus 1 and 4k plus 2, or just 4k or 4k plus 1 or 4k or 4k plus 3, some such thing, I do not know, or 4k plus 1 and 4k plus 2, I have no idea. Okay, but we want to find out. How will I do that? So again you have to understand, I want to use divisional algorithm. So if I want to use divisional algorithm, then okay, n has to be divided by which number? I want to say it is of the form 4k plus something or 4k plus something. Therefore what should be your a? A must be 4. That is what you have to concentrate. Some of you have problem with this is you do not know how to use division algorithm. So your n equal to, let us say, therefore when I take a equal to 4 by division algorithm, therefore n equal to some 2k, sorry, 4k or 4k plus 1 or 4k plus 2 or 4k plus 3. Do you understand this? Yeah. So we just look at each and every case. So when n squared will be 4k squared, which will be 16k squared, which is 4 into 4k squared, therefore it is of the form some 4k. Now don't worry about this case, some k, right? And suppose my n is 4k plus 1, then n squared will be 4k plus 1 whole squared, which is 16k squared plus 8k, right? 2 times, yeah, plus 1, therefore 4 into 4k squared plus 2k plus 1, that is 4m plus 1, therefore it is of the form, let me write 4m plus 1. Okay, now suppose n is of this form 4k plus 2 whole squared. Okay, so I can write 4k plus 2 already as 2 into k plus 1 whole square. Do you understand that? 2, sorry, I am making mistake. Let me do it so that I don't get confused. That is going to be 16k squared plus 2 into 8, therefore 16k plus 4, right? So this is some multiple of 4, right? And suppose n is of the form 4k plus 3. So again 16k squared plus 4 into 3 12, 12 into 3 24k, right? And plus 9, therefore that I can write as 16k squared plus 24k plus 8 plus 1. This I can write as 4 times m plus 1. So what is the result? Result is for every integer n squared is of the form 4m or 4m plus 1. That's it. Yeah, right, very good. Okay, so there are few more problems one can do. So there are few more problems using division algorithm one can do, but as I said, there will be thousands of problems one can keep giving. At some point or other, enough is enough. Okay, I taught you the trick. What is the trick? Two things important: division algorithm, and more importantly, uniqueness. Second thing is, whenever there is something about divisibility, some number is of this particular form, then that allows you to identify what A I have to use in division algorithm. That is the only thing you have to learn. After that, you know. Okay. And if I think of one or two more examples, interesting examples, I will do it in the next thing. Otherwise, we'll go ahead. There is a very beautiful theoretical application. Hi, I seem to have some extra time, so I'll give you a beautiful theoretical application of division algorithm. Let us get started. So let me share the screen. Theoretical application of division algorithm. Okay, let's start with an integer n. Then look at SA all multiples. That is, as I said, it is m times a, where m is an integer. Right? Then SA has two properties. Whenever x is in SA, then minus x is also in SA. Why? When I say x is in SA, what does it mean? There is an integer m, so that x is of the form m times a. Therefore, what is minus x? It is minus ma, but I can write it as minus m times a. Therefore, it is in SA. Right? And 2, whenever x and y belong to SA, then x plus y also belong to SA. Why? Because as I said earlier, there exists m, n, integer, so that x is m times a, y is n times a. Therefore, x plus y is m plus n times a. Therefore, that's also in SA. Right? Therefore, if I take an integer a, look at all multiples of a, then that set SA is non-empty. It has two interesting properties. If you want to say SA is non-empty, that is the first property. And zeroth property, first property is whenever x is in SA, minus x is in SA. Whenever x and y are in SA, x plus y is in SA. Do you understand that? So what happens if a is 0? SA is singleton 0, because these are all multiples m times 0. M is in Z, therefore it is a singleton 0. You understand that? Okay. Now we want to know the converse. That is, suppose AC is a subset of integers, non-empty, okay, has properties 1 and 2. Okay. Does it mean there exists an integer a in Z, so that S equal to SA? Yeah. Right. So we will look at two cases. Let us look at a proof. Suppose S equal to singleton 0, then I take A equal to 0. Then S equal to SA. You understand this? Right. Therefore, let us assume S is not equal to singleton 0. That means there exists A non-zero, so that A belongs to S. Right? Since A belongs to S, minus A also belongs to S, and A is non-zero, therefore either A is positive or minus A is positive. Right? Therefore I can assume, therefore S has positive elements, positive integer, that is natural numbers. Right? You understand? A and minus A both belong to S, one of them has to be positive. Right? Therefore it is a natural number. Therefore if I look at S plus, okay, the set of all x in S, so that x is positive, this is a non-empty element, because it has at least one natural number, and this is a subset of natural numbers. Remember, S itself is a subset of integers, and therefore S plus is a subset of natural numbers, and that's non-empty. Therefore what do you think I can use? I can use well ordering principle. right? Therefore there exists A in S plus such that A is the least element. Okay, now I want to claim my S is nothing other than SA. Okay, so how do I prove it? Let B belong to S. Okay, then I have to say B is of the form B belong to SA. That is right. What do you think I should use? It's a multiple of A. So when I want to show it's a multiple of A, the important thing tool is division algorithm. So by division algorithm, there exists an Q in Z and 0 less than or equal to R less than A, such that unique, they are all unique, such that B is of the form AQ plus R. Right? Now the interesting thing is, where does B belong to? B will belong to S, and AQ also belong to S because it's a multiple of A. Therefore by second property, B minus AQ also belong to S. But what is B minus Q? That is R. R belong to S. Right? This is R. Look at that. Yeah. But I claim R is 0. Because if R is not 0, then 0 less than R less than A and R belong to S. Alright? And since R is positive, R belong to S plus. But R is strictly less than A. Yeah. Therefore this contradicts the assumption that or our choice that A is the least element of S plus. Therefore R must be 0. If R is 0, what does it mean? It means B is AQ. That means B is in S. Okay. Pause, review, proceed. It's a very beautiful application. When you learn modern algebra group theory, you will see what it really means. But we are going to use this in number theory also. You don't have to wait till you learn group theory. Yeah? Okay, we will stop here. We will meet again. Take care. Stay safe.